Yeah, so uh, in this question we are actually required to develop an finite state machine, an FSM, to detect the sequence 10110. So this would be like, if you have never studied FSMs before or don't know how to go about developing FSMs, this would be a good starter. I will go step by step on how to develop a FSM. Okay, so also we will be comparing the Mealy and Moore machine for this functionality. Okay, so we can develop a Mealy machine or a Moore machine for the this particular functionality, and we will see and compare for ourselves the differences between them. So let's start. So while starting an FSM, there should always be a reset signal and a base state. So let's name it S naught and RST, which signifies reset. So S naught is actually the state names doesn't matter. You might have heard S naught represents 0 0, S1 represents 0 1, or all that, but this only matters once you are making transitioning from the state machine to the D flip flops or flip flop level design. Okay, so as long as you are focusing on the building the FSM, state names doesn't matter. It might matter for some questions, like it would be better if you know what that state signifies or represents. You will understand it better when we proceed further. Okay, so for now this is the easiest way to start going through the building the FSM. Now S naught is the bare minimum state. It is waiting, this state, the machine is now waiting for inputs. Now we are detecting the sequence 10110. Okay, I'll write it 10110. Okay, now because it is waiting for inputs, if I get a 0 uh, at the starting, okay, it doesn't matter if it gets the state 0. If it would only matter if I get the state 1, and then only it should proceed to the next state. So as long as I am getting a 0 at the starting state, this is the S naught represents the starting state. I don't care however many zeros I get, I don't care. Only if I get the input 1, okay, the D in, let's visualize this state machine as kind of a black box wherein I have this D in. I have a serial input, serial data incoming, and I have the output will be high whenever the sequence this is detected. Okay, 10110. This is the virtualization. Okay, abstraction, if you can call it abstraction. Okay, so if and only if I get the input 1 while being in the base state, I would start going through detecting these sequence. If only this sequence is detected, then the output would be 1. Okay, now I got 1. I'll name another state S1. Okay, S naught, S1, S2. As I told, naming doesn't matter, only go by the functionality. Okay, now this state represents the that I have got 1. The first number is matched in the sequence. If I get a 0, then it would match these two numbers. Okay, 1 0. And then if I get a 0, then I'll go to the next state, some other state, because this state S1 represents that I have matched only 1. This S2 on the other hand represents that I have matched 1 and 0 both. So the thing that is to be matched is 110. Only that is remaining. 10 is already matched. If I get a see, another thing, the only possibility in this case, because I am giving a binary input, is either you will get a 1 or a 0. Okay, so I have written both possibilities for this state S naught. If I get 1, then go to this state. If I get a 0, then remain in this state. If in for s the state when s1, if I get a 0, go here. If I get a 1, then stay here, because already I got 1, and any incoming ones would only add to this sequence, like 1 1 1 1. If I get a 0 1 1 0, then from here it would detect the sequence, not from here. So as long as I keep getting ones in while being in the state s1, I will loop around the state s1. So for both these states, okay, all the possibilities are covered now. Okay, now I am in the state s2. S2 represents that we have matched 1 and 0. Now if I get a 1, then move to state s3, or if I get a 0, what would it do? 1 0 0. If I get a 0, the pattern is not matched. If you get a, see, the pattern is ruined. Okay, so you will again go to the previous state, like represent here. So if you get a 1, then you would move to the next state. If you get a 0 here, then you would go back to the starting. Okay, I hope you understood it. Now I am in the state s3. What s3 represents? I have matched 1 0 1. Okay, s3 represents the pattern 1 0 1. Okay, matching pattern. Now from here, for the state s2, both possibilities are covered. Now s3, 1 0 1 is detected. If I get 1, then move to next state s4. If you get a 0 1 0 1, I have got, if I get a 0, it would represent the same state as this. Okay, so what I told, the state s2 represents the pattern, the matched pattern 1 0. So here also, if I get 0 while being in the state s3, you would go to s2, because the state s2 actually means the matching pattern 1 0, because we are to detect 1 0 1 1 0, but the pattern is ruined here if you get 1 0 1 0. So this part is matched 1 0 1 1 0 1 0. If you get 1 1 0, then this part will be matched. So you have to go accordingly. Now I forgot one thing to tell you. We are actually detecting overlapping sequences. Okay, what overlapping sequences mean, you might have guessed by now. Overlapping sequences mean, like take this example 1 0 1 1 1 0. Okay, so this part was matched. Okay, till this part it was okay. Then this 0 ruined the whole pattern, but this part is actually matched. So this is what is called overlapping pattern. Okay, I'll give a more good example. 1 0 1 0 1 1 0 1 1 0. Okay, so this part is matched, and this part again is matched. Okay, 1 0 1 1 0. So you will get the output high at 2 times, once here 1 0 1 1 0 here, and again at 1 1 0 here. So it will be matching the overlapping sequences. Okay, now for the state s3, you have both the possibilities 1, and if you get a 0, go there. So the state s4 represents the matched pattern 1 0 1 1. If you get a 0 here, then you will complete the pattern matching, and you would make the output go high. Okay, so if you get a 0, this means, see, here you got the pattern 1 0. So you would obviously, because we are matching overlapping sequences, we would naturally go to the sequence where to the state where 1 0 was matched, and the state where 1 0 is matched is s2. So we would go to s2 if we get a 0 1 0. Okay, if we get a 1, what does it mean? 1 0 1 1 1. It means you have detected this one, starting one. So if you get a 1, go back to s1, where the first one of the sequence was matched. Okay, this makes sense. Okay, now that we are over with the sequence, the FSM, let's try if by inputting different sequences if our FSM is truly correct. And one more thing, if I get a 0, this is where the output will be triggered to 1. Okay, now um, let's take the sequences 1 0 1 0 1 1 0 1 1 0 1 1 1 0. Okay, so from our knowledge we will see that the output will become 1 here and the output will become 1 here. Okay, so 2 times the output will be 1. Let's see how this FSM reacts to this sequence sequentially. So first this bit comes, then this, then this, then this, then this, then this, like. Okay, so from right to left the input. When we press the reset button, we are in state S0. We get a 1, then we move to S1. We get a 0, then we move to S2. We get 1 again, then we move to S3. We get 0, then we move to S2. we get uh, we get 1 again, we move to S3. We get 1 again, we move to S4. We get 0, then it will trigger the output high while going to state S2. We then get 1, then move to S3. We all then get 1, move to S4, then get 0, move to S2, triggering the output high. That is like the output will be high 2 times. So I think this you can see for yourself that verify that this FSM is working correctly. So this is indeed correct. Now this kind of FSM is called Mealy Mealy machine. Okay, so why Mealy? Okay, so the simplest definition would be Mealy machine is where the output depends on external inputs. So what are the external inputs for this FSM? These, it is DN. The input sequence itself is the external input. No external inputs are being applied to this FSM. So how would I go by writing this the output equation of this FSM? The output equation would be, whenever I am in state S4 and I get a dn to be 0, so I will represent it by dn bar. So the output equation would be S4 dn, and you see that S4 is internal. The S4 belongs to the state machine. Only this dn is what is making what is a external input. So this from the output equation itself you can make out that if it is a Mealy machine or a Moore machine. For this video we will we have done Mealy machine. In the next video, upcoming video, you will learn about the Moore implementation, and we will compare these two in the upcoming video. Okay.